Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Alhamdulillah. We in this video session we continue what we have left from the previous video. In the process of making this tightener for our glass suction cup mount holder. So in the previous video, I've shown you how we make this cylindrical object by using wrap. Since we have the pattern, the unwrapped pattern, and we wrap it along the vertical surface of the cylinder. So we use wrap and we emboss and we do cut extrude of the inner circle. Then we have the hollow cylindrical shape. Okay, for this video session, I would like to continue the other parts of this component. As I shown this image. If you look on this image, we have done this component, and the other one here, what I'm going to show you how I did it in SolidWorks is the knobs here, the handle here. If you look the way the structure of this handle is that we have a cross-section shape here, so we can use in SolidWorks cross-section shape here as long we know the dimension, and we can use a boss extrude toward the surface of the cylinder. In order for us to do boss extrude, we must first know the axis, the construction line where we can put our construction plane here, our sketch plane at the end of this construction line. If you look, in order for us to put the construction line, the line must be passed through this flat surface. So the line must be passed through from the center point of the cylinder until then it goes along this flat surface in the middle of this edge of this flat surface, and if we know the distance from this center point to the edge of this cross section where we can at the edge of this handle, so as long as we know the distance, then we can do the construction plane. Okay, later on in this video also I will show you, beside if you look on the other view, if I show you at the bottom of this component, we have some hollow shape with thickness. We have hollow, we can do shell in SolidWorks, and with thickness. And if you look, the certain portion of the of this handle is we shell it, but not at the edge. The edge and these three edges will be shelled, but not at the edge. For in this video, I will show you how we use boss extrude. But we must make sure that we don't, when we use boss extrude, we don't merge the object. We untick the merge the result, so we can do the shelling on the selected surface. So let me show you how I do it in SolidWorks. Let me minimize this view. Okay, the starting point from here is that we must, as I mentioned, okay, in the image we have, if we go back to our previous, okay, in this image we must know the center point. We must draw the center line here from here to the end. The distance is 29. I already measured it is 29 from this center point to here, so the point must be passed through the middle point of these edges. So if you look from the when we look from the top view, the center point of the cylinder, the problem here is that our flat surface here is not in position where we on 0 degrees or 90 degrees, but it is somewhere a certain degrees there, a certain degrees from center point. So we must draw the line, so we must make the construction plane. So I started by select this bottom object, I make it a construction plane. So at this construction plane, I go to normal view. So since this normal view is at the bottom, so when press spacebar again, when we go to normal view, so it will toggle to the top view. So our line must be passed from this point to the middle of these edges or these edges. So let me draw the construction line from this center point. So let me snap it to the middle point. Okay, to the middle point. So since let me check the dimension, the length of the path. Okay, the length is 29. The length here is 29. So if I, in the sketch view, if I put smart dimension, if we do a line dimension, the length here will be, so since this one is already, we already set a constraint there, we have a relationship here, so we must delete the constraint. Carefully select the constraint when delete it. I have to make sure I off my dimension first. Off your dimension, then we select, carefully select the constraint, and we delete it. So then we do the smart dimension. Make sure it is a line dimension, and the distance is 29. Okay, then we have our guided line for us to do our construction plane. Okay, let me go to the right view. Okay, so we have our construction line here, so we can put our plane here. So let me exit the sketch. Okay, then we, what in features, we do reference geometry plane. Okay, then we select the line to be our first reference, and the second reference we select this endpoint. So we have our sketch plane. Make sure to check on the set origin on curve and click OK. Okay, now we have our construction plane where we can do our sketching, the profile of our handle, our horizontal handle. So as long as we know the dimension, so this view cannot show you exactly the cross section view. Actually, I know the dimension of the cross section here, the cross section of this handle. I already have the dimension. So let's make this sketch plane active, and we go to normal view. Since if you look on this image again, our cross section, the handle, so at this endpoint is a continuous surface, so the top part of our cross section is aligned at these edges. So I will draw the line at this middle point, and somewhere around that point. So I make a rough sketch of the cross section. Make sure that it's snapped to the axis, vertical axis. Right. Okay, then I do the center line to make a mirror. Then use mirror entities, select this object, and the mirror about, select this line. Then I click OK. Right. So the next step is for us to put the dimension. Since I already know the dimension, okay, the dimension is here is 3. Here is 12. And the height is dimension from this point to this point. The dimension from this point to this point. Let me do it again. Dimension from this point to this point is 15.56. Okay, after we have put the basic dimension, so we can do some adjustment on this point. So basically the cross section will be approximately like this. We have kind of sorry that my laptop is a really old version, quite slow. Okay, I do some little bit adjustment to get roughly the basic sketch of this part. So it's approximately like this. Okay, so this basically this is our sketch of our cross section. Okay, then what I will do, make sure that we exit. Okay, then we go to features, then we will extrude. We will extrude boss, not on this direction, so make sure the direction is reverse. So we don't use blind. What we use is up to surface, and we select this vertical cylindrical surface, so it will directly extrude it toward that surface. Okay, so since the surface of the cylinder is curvature, so we have a curvature cut. At the end of the surface is curvature, so don't worry about it, because later on we'll use there will be a cut revolve here. Since from this image we have a cross section here where we can do cut revolve to form the cutting surface at the bottom. Okay, alright. Okay, one thing that you must make sure that you don't click the merge result, since I will explain you later why you shouldn't. If you put merge result, so later on when you do the shelling, so the shelling will read both. It's quite difficult for us to do shelling, because since when we merge, so this component and the component will be together as one. So what, for the time being, at this for this component to be extruded here, so I just uncheck merge result. So then I click OK. So basically I have the shape of the of the lever. Okay, later on, then I do some fillet. Radius is 1 at these edges and these edges. Click OK. Then we do another fillet, radius 5 for these edges and that edges. Click OK. Then another one is another fillet will be radius 12 for these edges and that edges. Okay. Okay, now we have the basic geometrical shape of our lever component. So then the next step is, when we go to the bottom view, there should be a let me go back to isometry. Okay, if we zoom in, we go to the bottom view. Okay, since as shown in this image, in the bottom part of the, okay, let me show this, not this one. You got to search through the image. Yeah. Right. Okay. This is a bottom view of this component. So we have a shell here. We have a shell here with a thickness. In this case, is 1.5 millimeters. So we select the right surfaces for us to do shelling. So in this case, so what we will select, we do shell. Alright, let me put you to the right. Okay. Then we go to shell. The thickness about 1.5. Then we select this space. And this face. And we show preview. So we have shell here. For this case, the thickness is 1.5. Then you click OK. So we have this kind of geometry. Okay. Okay, let's compare to the image here. This one. Okay. All right. So what is our next step? Go back to right view. Sorry, I don't know why my computer is running so slow right now. Let me zoom for isometric. Okay. Okay, right. So we have the handle there. We have the handle. So the next step for us to do cut revolve here. So in order for do cut revolve, we got to know the cross-section profile of the curve for us to use revolve, and we cut at this bottom portion, bottom part of this handle. Okay. If you look at this image, okay, actually this image is toppled upside down. So if we have a cross section here, so this component actually will be mounted on one component here in our project. So maybe I could show you the right image. Okay, if you look at this image, As you can see, this is our tightener. Our tightener will be mounted on this what we call this support structure, where we have at the bottom is our suction cup. So this dome shape structure here. So as long if we can copy the sketch profile of this, I have already done this this component, this vertical support here, where we have the kind of dome when I have the cross profile here when I do revolve. So we can copy that sketches from the right plane. From this component, we copy the sketches where I do revolve, then I can put it, that sketch curve to be paste in this file, so that I can use that reference for me to revolve cut this handle component here. We cut it by, as long as we know we import the sketch from the other files, so then we can paste it here, so we can revolve it. Okay, the file, let us look at this file. The component is okay, this bottom support structure. Okay, this bottom support structure, if you look, I've done this part. So we have a slot. It is we have a vertical cylindrical column here, so where we mount our tightener here, our ring with handle. So what we need in this file is the cross section of this dome shape, where we can copy the sketch from this dome shape. If I select this dome shape, if I edit the sketch, then when I go to normal view, so I have, if you look, if you see in this image, we have the profile of the of this component where I do revolve. So what we need in this cross section is the upper curve here, so I can copy the certain portion of this curve, certain part of this curve. So I select, what I need is only, I select this line and this line. Okay, and we go to edit, we can copy it, or Control C for copy. Okay, then in our tightener file, so we can paste it in the correct plane, either front plane or right plane. Okay, since let's go to, in this case, let's go to front plane. Okay, since the center of this cylinder is coincident with the center of the dome shape on the other files, so I make a new construction plane. From the front plane, so I go to normal view, so this is our front plane. Okay, in this front plane, what I did, since I have already copied the profile of the curve, so in this front plane, what I will do is I will paste it. Okay, I will paste it, since our sketch is not in the right position, so we can just drag along, but you cannot just simply, you have to do it accurately. So you have to, what we have to do next is we have to put some relationship, either coincident or where we can put our starting pointer to exactly at the origin of this cylinder. Okay, the next thing what we should do is we put a relationship. We select this point and hold down your control key and you select this origin, then we set the relation to coincident. so that our sketches will be coincide into this origin. Okay, then for us to do cut revolve, so we must have the close section. So let me add additional line here from this point to that point. Okay, all right, so we have our cross section there. Okay, then we do revolve cut. So our axis of revolution is this line. Then we click OK. Now we have our handle. Okay, now we have our handle for this part. Alright, okay, what's next? The next things to do is that if you look exactly at when we zoom in, we have some extra motion here. So what I have to do, either we can in this case it's slightly about few millimeter there, so what we can do, we can extrude the bottom surface here exactly toward that point. This bottom of this cylindrical object, we can extrude it along to this vertex or these edges. So what I will do, I select this bottom surface, make a sketch plane there, then I select these two edges, hold up my control key and convert it to entities. Now I go to features, then I extrude. Okay, we don't use spline. What we do is we have some option there. It's not up to surface, but at this time we use up to vertex. Okay, up to vertex. So we select this vertex. Since this is a vertex, this point is a vertex, so it will be extruded until this vertex. Okay, then we click OK. So then now we have our part. Okay, right, so we have our part. So the next thing to do, I have to put some additional fillet here, fillet at these edges, and also at that on the opposite edges, and also at the at the end of this as well as these edges. Okay, let's do some fillet. We put a fillet, and the radius is about 0.25, and we select these edges and also these edges. Okay, now we have our fillet, right? We have our fillet. Then the next one, we put another fillet at that edges. I think the radius should be the same, 0.25. Right, so let's see on the image. We have actually the fillet is okay. It's approximately the same. Okay. Okay. The next one, what I will do, okay, let's go to the appropriate view. Okay, the next one is we have done a shell, we have done the ring, the handle, fillet. Okay, what's next? Okay, the next thing to do is yeah, we have this groove pattern here. So how do we do it? Okay, I thought I could do it by using rib, but rib cannot. You cannot do rib for this kind of pattern. What you should do, you have to make there's a way in SolidWorks we call it intersection line, by intersection between the cutting plane and the object surface, so we can have the intersection line. Let me show you. In this case, let me put you in the right view here. Oh, I wish I could have a better laptop. Inshallah, ada rezeki. Okay, right. Okay. In SolidWorks, okay, what I can do is, in this image, we have a first groove pattern here in a certain distance. Since our construction plane here is at the end, so we need to make a the same parallel sketch plane with a certain distance here. So what we need to do is we can use reference geometry plane. So since let me cancel it. Since my plane, when you select my plane is active here when I press reference geometry plane, so it will automatically use this plane one, the one that I've selected as my first reference. So the next thing to do is we put at a certain distance in the other side. Not, if you look, it's already been set 10 millimeter on this direction, but we must go to reverse direction. So I make it flip. So the distance is not 10. In this case, like we have about few millimeter, about 3 millimeter or 5. So let me put it around 3 millimeter. Okay, let me enter it. 3 millimeter. Okay. Nope. Let's try around maybe 2. Let's try again. 2. Let me check. Let's try by 3. Never mind. 3. Press enter. Okay, let's go for 3. Then I can okay. So we have our new plane there. Okay. Okay, we'll make this plane active. Okay. So we have our plane active here. Then what we will do in SolidWorks, when you go to not under insert menu, what you do is under tools. Under tools menu, then you go to sketch tools. Then in the in this menu we have what they call it, intersection curve. We select intersection curve. So what intersection curve will do, this plane tool which is active, then we select the entity, select the surface where the plane will be intersect with the selected surface. So at this portion, select entity, we have to select the surface that the plane is cutting through. So for our case, all these vertical face, okay, until the bottom. So we have the face, so that means that the plane tool will intersect here, so that it will form a intersection curve. When I click OK at this point, so we have our intersection curve. So intersection curve is the result where the cutting plane intersect with the surface, so it will form intersection curve. This is another method to do it. Okay, now we have our intersection curve. So I will not do rib, since the rib we cannot do rib for this case. What we do is basically we will do extrude. Okay, I do some offset and we'll do extrude in a certain height for thickness. So firstly what I should do is I go to normal view. I do some offset. Let me zoom out a little bit. Okay, okay, you go to make sure you're on the sketch here, you do offset. You select the line to be offsetted, then the distance should be 1. I think 1 is too big. Let's say try 0.25. Okay, let's try 0.25. I think 0.25 is about right. So then click OK. Since if you look at this endpoint, so I got to draw a temporary line here, make it horizontal. Okay, then at this point I could extend it. So in here we have beside trim, if you scroll down, we have another version is extend. So we select this line to be extended to this line. So then only you can use trim. Okay. Same goes here. Draw line here. Horizontal. Then you use extend, not trim, use extend this line. Then you go back to trim, then you trim this line. So we have the profile. Okay, we have the profile for us to extrude. So when I go to little bit isometric view, then I can use features, extrude. Okay, not that direction, go to reverse direction. So the thickness, let's say we go for 1 is too thick, let's go for 0.5. For 0.5 also is too thick, let's go 0.25. okay, 0.25. then we have the this kind of geometry. Okay. Okay, what's next? What I'm going to do is I use a pattern. In our case, we don't use linear or circular pattern, so we have another option called not sketch driven, curve driven pattern, where we can the pattern can be also, you can use in this case, if it's directly in one direction, you can also use linear pattern. Let us try linear pattern. Okay, since we have okay, let me zoom it. So what we'll do next is we use a linear pattern. So we have the groove here, so we can use linear pattern. The direction is we can use this edges, our direction to that direction, and the number of pattern is 3. So what we will do is we use linear pattern. Okay, linear pattern. So at this area for linear pattern here, so this area for us to the direction. the direction of our linear pattern, so we need to, in this case, we can use these edges for our direction. Okay, our direction, if you look on the arrow here, it's pointing to that direction. If you, even this arrow can be toppled to, if you drag it, you can topple it to direction. But our case, if you select the arrow, make sure that it goes to that direction, you drag it to that direction. And these settings here, the distance either 5 or the distance between the pattern, between this post extrude, the distance, let's try 5. And the number of, this one is the number of seats, the number of pattern that we want to make along the direction. So in our case is 3. Start from the original one, 1, 2, 3. Okay, and then the features in this area, we don't use the direction tool since you only have only on one direction here. Features to pattern is what are the features that we are going to pattern. For our case, the features that we're going to do linear pattern is boss extrude. This boss extrude. So it already show you the preview. So I think the distance 5 is too far. Let me increase it a bit, decrease it about 3 millimeter. Let's compare it with the view. 1, 2, 3. I think it's about right. 3 is okay. Right. 3 is alright. Okay. Okay. 3, then we click OK. Okay, now we have the pattern there. Okay, what's next? What we should do? The next thing is we have to cut this bottom parts of this to pattern here, right? Okay, what we will do next is that we use the same approach as we do for the cut revolve here. At this, if you drag before this, we have a this handle before we cut it, so we use the sketch. Remember that I import the sketch from the another file, then I use cut revolve. Okay, cut revolve, so we cut the bottom portion of this handle. So then until at this point, and we have this pattern, so we know we need to do the same procedure where you do cut revolve from the same sketch. So what we will do is we copy the sketch. See if since I make this sketch on the sketch that I imported, the sketch on this first, our previous cut revolve, the sketch, make it active. Oh, sorry, I make it active. So let's go to the normal view. So I select the whole sketch here, then I can use edit, I can copy it to the clipboard. Okay, I copied it, Control C, copy, then exit. Since the sketch is on the front plane, our previous cut revolve is on the front plane, so what we have to do, we have to make again the front plane, we have to make a new sketch plane, so we can paste our, so this is our new sketch 10 is from our new front plane. Then go to normal view of it, then I can paste it in that plane. So we have to do it again, put a coincident there. So we need to put at this corner, this point should be at the origin of this sketch plane. Okay, so what we do is we select this point and that origin to be coincident. Okay, to be coincident. Then what's next to do is we will do what you call it in the features, revolve cut. So our axis should be this vertical line, then we click OK, and then we have our finish component. Right, I think that's okay for this component. I think we have done it. We have done for this component as this image. Okay, the bottom part we have shelling here. Not this one. No, where is it? Where's my image? I got to let me check. No, okay, never mind. I think we have done this part, okay, for this tightener. So make sure that we save it, save our file. Okay, I think that's all for this session. Thank you very much for watching and listening to this video. Assalamualaikum warahmatullahi ta'ala wabarakatuh.